All right, let's talk about LLMs. I mean, you're hearing this acronym everywhere, right? It feels like it just popped up overnight and is suddenly powering everything from our chatbots to our writing tools. So, what on earth is a large language model? We're going to break it all down, move past the buzzwords, and give you a real blueprint for understanding this stuff.
So here's our game plan. First, we'll cover the absolute basics. What even is an LLM? Then we'll get into just how large these things really are. After that, we'll uncover the secret sauce that makes them so powerful. Then we'll look at how they're actually built. And finally, we'll see where you're already bumping into them, probably every single day. Okay, first things first. Let's start right at the beginning. Before we get into all the crazy stuff they can do, what are we even talking about when we say LLM? Seriously, this is the big question, isn't it? What is a large language model? And believe it or not, you've probably already used one today, maybe without even realizing it. So let's pull back the curtain and see what's going on under the hood. Okay, so here's the core idea. At its heart, an LLM is a special kind of neural network. But the important part is what it does. It's all about doing three things really, really well. First, it has to understand human language. Second, it needs to be able to generate its own new text. And third, it has to respond to you in a way that feels, well, human. And that term, neural network, just think of it like a digital brain. Seriously. The whole concept is inspired by the way neurons connect in our own heads. It's this incredibly complex web that's just amazing at spotting patterns in huge, and I mean huge, amounts of information.
You know, all these terms can get super confusing. AI, machine learning, deep learning, where do LLMs fit in all this? Well, think of it like a set of Russian dolls. The biggest doll is artificial intelligence. That's the whole field. Inside that, you've got machine learning, then an even smaller one, deep learning, which uses those neural networks we just talked about. And finally, right at the very center, you find large language models. They're a super specialized part of deep learning that's all about language.
So we've got the language model part down. But what about the large? Okay, this is where things get kind of mind-boggling.
Now, large isn't just some casual word they threw in there. It specifically refers to something called parameters. And a simple way to think about parameters is that they're the individual connections inside that digital brain. The more parameters you have, the more powerful and complex the model can be.
So how many are we talking about? Well, take GPT-3, which was a huge leap forward. It has 175 billion parameters. That's just an almost unimaginable number of connections, all firing away to understand and generate language. And this chart just puts it all into perspective. I mean, look at this. GPT-1 started with 117 million parameters. Sounds like a lot, right? Then GPT-2 jumped to 1.5 billion. But that leap to GPT-3, 175 billion, it didn't just grow, it absolutely exploded in just a few short years. And all that power comes at a cost. A really, really big cost. To give you some idea, a single training run for GPT-3 was estimated to cost around $4.6 million. So yeah, this isn't something you can just fire up on your laptop at home. So what happened? What allowed for this insane jump in scale and capability? Well, it turns out there was a secret ingredient, a single technological breakthrough that completely changed the game. And here it is. Attention is all you need. It's the title of a research paper from back in 2017, and it introduced something called the transformer architecture. It sounds kind of simple, but I'm not exaggerating when I say this paper turned the entire field of AI on its head. So what was the big deal? Well, before this, models struggled with context. But the transformer gave them a way to pay attention to different words in a sentence, to understand which words were most important. This let them grasp long-range relationships and nuances in a way that was never possible before. It was the key that unlocked everything we're seeing today. Okay, so we know what they are, we know they're huge, and we know the tech that powers them. But how do you actually build one? Well, it's a really cool two-stage process. It all boils down to these two key phases. You've got pre-training, and then you've got fine-tuning. Let's take a look at what each of those means.
Think of it like this. Pre-training is like getting a general education. The model reads a massive chunk of the internet, books, articles, websites, to learn about, well, everything. It builds general knowledge. But then comes fine-tuning. That's like going to medical school or law school. You take that general knowledge and train it on a much smaller, specific data set to give it a specialized skill.
And this is happening all over the place. A company called Harvey fine-tunes a model on tons of legal documents to create a tool just for lawyers. SK Telecom uses its own customer service chats to build a better chatbot. And JP Morgan uses its private financial data to create a custom research analyst. Fine-tuning is how a generalist becomes an expert.
Okay, so how does this all come together for you and me? The thing is, this technology isn't just stuck in some research lab. It's already out in the world, and it's a part of our daily lives. I can almost guarantee you've used an LLM recently. They're helping us create content, everything from poetry to computer code. They're the brains behind those advanced chatbots that actually understand what you're asking. They give us instant language translation. They can even read a super long article and just give you the main points. They're quickly becoming invisible, but absolutely essential. And honestly, the people building this technology believe we are just scratching the surface. The number of ways these models can be used in every industry you can think of, from medicine to education to entertainment, is just growing by the day. Which really leaves us with one last huge question to think about. We've already seen this incredible exponential growth. So as these models get even bigger and even smarter, what's next? What new abilities are they going to unlock that we can't even imagine right now? The blueprint is still being written, and it's going to be fascinating to watch.